right. How's it going, everybody? Welcome back. We'll get right into working on this lightsaber again. I'm still trying to figure out ideas for updates on the website and how to manage this channel going forward and exactly what I'm trying to do here. But, so yeah, if you continue to have ideas regarding that, please let me know. Otherwise, just, ask questions or give suggestions, and I will do my best to figure out how to make all this work. All right, let's see. So last time we made the USB-C connector, which is this right here. So I think the first thing we'll start with today is connecting up the appropriate lines, and then I think we'll move on to the buttons after that, which that should be fairly easy. Nothing there yet. And to reiterate what we're doing, this whole diagram right here is the entire circuit board that we're trying to make, and we have done everything on the bottom here up through this and the teensy right here. So we just need to finish connecting up a few lines to finish that part up, and then we'll jump on these buttons. And then after that, I guess we'll move to the screen, and I'll probably wait to do the speaker and the motor last because those will be the trickiest. I'll do the neopixels and accelerometers before that. So yeah, I think that all makes sense. All right. So we need to connect the data on this USB connector to this, but we don't want to connect the power. The power needs to go into the recharge circuit, which would be on the power supply here. If I can get it to open, there it is. Oh, let me turn the music back on. Also, these bounties that you see down below are still good. So if you want some Dogecoin, then see if you can claim one of those bounties. All right. So where's our power in? USB 5E. That's what we're calling it. That's right. I was thinking about it too. We might have to have a way for the teensy to be able to tell if something's plugged in, like if it's plugged into the USB power. So that might be a thing too. All right, let's do, I tell you what, let's do ground then, or actually, let's slide this over. Like right there. And then USB 5. Let's do the power first. Also, let me know how your day's going. I'm interested to talk, so. We call it USB 5V. I think that's what it was. Yep. All right, so we'll copy that. I don't need that one. All right. And then for the data, those have to connect to those lines here, this USB in D plus and USB in D minus. I don't know which one of these two has to connect. I think it's number 1. I also don't know what the rest of these are for, the CC one and the SBU one. All right, but the good thing is I can look that up. All right, so they're in the spec, they state this exactly. Let's see if I can find it. Okay, so interesting. I might have missed a couple things here. So I'm just looking at this stack exchange thing. This is the chart they pull from the USB spec. So these go to ground, these go to the voltage. That makes sense. CC Note 1, pin A5 of the USB Type-C plug shall be connected to V-bus through a resistor. 56 kilo ohms plus or minus 5%. Let's see, B5. Doesn't say anything about that. All right, DP1 and DN1, D plus D minus, A6, A7. Okay, so I was right. All right. So D plus here needs to connect to DP1 down here. All right, D plus and D minus. And then we'll do the same thing up here. Oh, wrong one. Okay, so those are connected now. SBU1, CC1. What is the SBU1? Is that B5? No. B5 is CC. What is SBU1? A8. That's not listed. Or B8. Neither of those are listed in this spec. So I guess they're just unconnected. But A5 and B5 evidently have to do with the voltage control. So those of you familiar with USB-C know that it supports actually more than 5 volts. You can, I think it goes up to 20. And based on a pulse on that line and how long it is, I think it controls like the voltage that it's requesting. Effectively, to keep that from happening, you need to tie it to with a resistor to the 5 volts. I don't think in our case it matters because we're not actually doing anything with it. Like, we're not going to care what it is. And the plug coming in is a USB micro, so it won't have that in there. But we should do it just in case. Oh, no, maybe it would because of the host. Yeah, never mind. I changed my mind. It might matter. All right, so let's run this out here. And run this up. And then I need to get a 56 ohm part, 56 kilo ohm part. Also, I've just realized I haven't added this connector or the teensy to the bill of materials. So I probably need to do that. All right, so that's J9. Let me go ahead and put that on there. So let me do this, and then I will find the part that I need U4. I did include it, just not actually find it online. All right. Teensy 4.1. Nothing in stock, really? That's shocking. Costs an extra $2 to get it with headers. It's a popular item. I'll include it anyway. We'll go find it somewhere else if we need to. All right, and then for the Molex connector, let's see if they have it in stock at least. They do. Look at that. I like how Molex has always used just a big number. Big meaningless number is their part number. I guess the variations on their product mean that they have to do basically something like that. But all these other companies try and create like descriptive part numbers so you can kind of figure out what they are. All right. Now we need to find a 56 k ohm resistor. So let's see if we can find that here. All right. In stock, active. We want an 0805 package. And then we need a resistance, 56 kilo ohms. Come on. $40 remaining. And then, oh, all of those are fine. It needs to be 5% or better, so I think all of that is acceptable. We'll do cut tape. Get rid of some of them. Okay. Wow, some of these are expensive. Electronic components, 10 cents. I like this one. All right, well, let's see if we have a part here. No model. That's not the right part. Oh, it is. It's just on the reel. All right. Let's see what else we can find. Just going through like the 10-cent options. Let's try this one. From Stackpole Electronics. Okay. Hey, it does have a part. 56 k ohm. That picture does not match. but that's okay. All right, we'll use that part. Works for me. R7. Let me add that real quick. Let's see here. All right, there we go. And then I don't need this anymore. Turn this vertical. Rotation 90. And we'll turn off the name. I don't need that. Can I turn on the value? Does it have it? Yeah. Wait, something seems weird here. Just gonna delete this line and start over. Okay. All right, there we go. And I think that's good. So we have our positive connected, negatives. We need ground. Then we need to connect all those up. All right. I think that's everything. Oh, we need the CC connect on the other side. Let's do this. There we go. Okay. These don't need to be connected, and I guess these don't need to be connected either. So that should be everything on our Molex connector, and everything that goes here, and the stuff that connects to the power as well. All right, just to double check everything. Let's validate it. No errors. Looks good. And then we'll push these changes. Looks good. No issues, except for this issue. Unknown pin R7-2. TNC. I think something's not connected. Alright, I think all that looks good. That's weird. 7-2 to USB 5V. Unknown pin. Failed to add class member. Component R7. Okay, well apparently it did it anyway. Do we see R7 anywhere? Yeah, it's down here. Oh, it just stacks things on top of each other when they show up later. Alright, so that's on. All this stuff is connected. Yep, ground is. Data. The power connector's connected. Yep. SP5V. Alright, there's a lot going on here, but yeah, it looks all good. Alright. Cool. Let's go ahead and save all this. Y'all will have to remind me when I'm done to make sure I make these projects public. Hold on. It's loading. Alright, what would be next? The buttons. I don't think there's any models that exist for them already. The push button is going to be easy. That's just a couple of places to mount it. Although it might not be a bad idea to do a connector or something to make it easier to change out if it breaks. I might do that, actually. The problem is you got to get the connector mounted onto it somehow. Alright, this all looks good. Alright, buttons. So we need this one, the Adafruit 3350. Just curious if that part exists. Maybe. Let's try Adafruit 3350. Yep, no model for it. I think a connector would be a really good idea, actually. To make sure that it's easy enough to change out. Yeah. Let's see what we can find. I don't know if I want to use the same one that I use for the batteries. Let me go ahead and add the Adafruit part to the bomb here. I wonder if I should have a different thing for stuff not on the board, like a different list of mechanical kind of stuff. That's probably a good idea, actually. number link. And we'll rename this assembly items, I guess. All right. Well, this description is not very good. Doesn't tell size or anything. All right, there's our push button. And then if we get a connector, we'll have to add the connector that's not on the actual circuit board to this. I'll have to get a tool to crimp some wires and things if we pick it. All right, so we need to pick a connector. Fortunately, there are a lot of those to pick from. Those fuel sockets. If we want a socket, I think. Yeah, probably. We want something small, but we also want something that will lock, because this thing will get banged around a little bit, so. Stock active. And then I really just gotta find something. Probably something right angle. Two positions. Yeah, that's two positions. I think it interpreted that as like 2 rows or something, apparently. I want a surface mount right angle through hole part. Through hole right angle. Here, let's try that stuff. See what this gives us. If we just go to the through hole, because that will likely be the strongest. Alright, I'm going to try the positions again. 2 positions. We're down to just a few now. Is there a way to filter if it has a locking mechanism or something? Some of these are excessive. Let's see. There's no lock on that. I think I'm searching something wrong because this shouldn't be that hard. Hold on. Let's go to a different category. Let's go to headers. Okay, something like this is more what I wanted. All right, let's go for in stock, active, and then we're gonna find a right angle mounting type. Through hole right angle, surface mount right angle. All right. Let's do the 2 positions. See what this gets us. Yeah, something like that is really strong. Although that might be kind of big, but that's not bad. The Molex part, should be fairly easy to work with. And source later. How big is it? .9 meters tall. That's kind of sizable, but not terrible. Oh, does it lock though? Recommended. I don't know if it says anything if it's a locking part. Plus something without coin, copper underplating. Yeah, I don't know. I don't want to risk that. Let's see if we can see an option here. Styles, routing, mounting, termination, fastening type. We just basically threaded spring lock, push pull, probably don't want locking ramp, latch lock, latch holder. We don't want a friction lock. Those are probably all fine. Okay, is it still listed here? Or is that a different part? That looks like a different part. Let's take a look at this one. Ooh, that looks like it might be kind of the perfect kind of thing. As long as it's, yeah, it fits 2, so. Oh, you know what? The button, though, that button doesn't have just 2 wires. It has a lot of wires, so we're going to need something bigger than just 2 positions. How many positions are we going to need? What is this? Hold on. I completely messed up how I was thinking about that. I was just thinking of it as a single on-off button, but I forgot that it had the PWM wires and a ground and everything. So this might actually get a little complicated. All right, what are we looking at here? Here's dimension. How many contacts are there? 2 gold contacts for the button, 4 for the RGB LED ring, 1 anode, and 3 cathodes. Point there doesn't need contacts to ground as you desire. There's a built-in there's a built-in resistor. That's cool. If you want to use this with a higher voltage, add a 1K resistor in series with the LED cathodes to keep the LED current around 20 milliamps. You can PWM the RGB pins to make them any color you like. Cool. So, yeah, so we need 6. All right, so let's see if that's even an option here. And then we'll view how big this thing is. Just make sure we're not gonna 6. Refer to drawing. Those are probably forces. Might have to go look this up on the Molex website to get the drawing. Hang on, it's loading. Really? I search a part number and it can't give me an actual like specific thing? All right, what does the data sheet call this? Product specification, title, or positive lock. Let's try just searching this. Their slogan on the website is creating connections for life. Really, no results. How is that possible? So this is just the spec for it. But I need a drawing. Does it give a part number for the drawing? Refer to the drawing. It doesn't. That's disappointing. Let's see. Their website is really slow. Wow. All right, not sure what to do there then. I think that's tanking my internet too. Sorry if the video gets choppy. All right, doesn't look like I can find it easily. So I guess I'm gonna pick something else. Let me go and change the number of positions to 6. That'll help me out a little bit. All right. Maybe this will work. All right, that's better. How big is it? This is all the tape and reel stuff. Oh, there's a lot of numbers on this page. 3.4 millimeters tall. It looks like it's a surface mount, not a through hole. But I think that'll be okay in this scenario. Well, maybe. Come on. There we go. Yeah. It's like a surface mount that you can back up to something. But it should have pretty good connection because of the big pads, so I'm not that worried about it. Position 149. All right, cool. I like this one. You know, now that I'm thinking through it, this might, I don't know. This is probably too big though. Let's see, the casing, 1.25 N plus 0.25 N being 6. Yeah, that's a pretty big part. I'd like to find like a semi-common connector type to use so I can just get a bunch of them. But I think I'm going to need something smaller, honestly. Could do something like this. I like that. And it's got a clip and everything. I like that a lot, actually. I think I might use these. Length, what's the width? Does it say 3 millimeter pitch though? That's pretty sizable. It's low profile, which is good, but it might still be too big. Where's the size chart? 21.64 millimeters. So a couple centimeters wide. That's pretty big as well. I don't know. I don't feel good about that. I just want to make sure it's, because like space really is going to be a premium here, so inside this thing. Smallest they offer is a 1 millimeter pitch. Let's see what parts have that. Okay, maybe. Some of these are pretty beefy. All right, what about this one then? Well, this is the brochure. I do like the low profile of it and everything. I need a drawing though. I need a size. Pico lock wire to board connector system. All right, we'll try their slow website again. This will probably tank my frame rate again, so I apologize. I don't know what is up with their website, but it is horrible. I just want a drawing. Well, that worked. I was searching on Google generically, and then it comes to the... Never mind. Hey, here we go. Look at this. All right. So maybe this will be the part we need. So size A for a 6 circuit, 9.8 millimeters. That's like half the size. That is already way better. I think this is perfect. Let me double check. So we need the... This is in stock. Let's check the mating part. Does it come with the contacts? It looks like it does, kind of. Well, no, but you gotta... Oh, but it's connected to the board through whole components. So, yeah, it already comes with the contacts in it. So just this, we'll have to, with this one right here, the connector that goes to it, we'll have to buy contacts and crimp them and put them in. But that shouldn't be that bad. There we go. Come on, load, 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 load. I'm probably just tanking my internet right now. Yeah, okay. Yeah, you can see where they go in. All right, that'll work. And then hopefully it'll tell me. I'll have to look up the other part and see what connectors go into it. I imagine it's these ones right here, though. Oh, excuse me. No photo available. 0691. Really? I thought I had one. There it goes. All right, so we're going to have to add that as a connector. And I think we'll just have to go ahead and make the part. Let me check. With this kind of stuff, because it needs to be so specific, I really don't want to get in the world of trying to find a part that's already made. We can just go... We learned fairly recently that it's not that hard to do. Now that I'm kind of back in... Now that I've done it a few times, I'm not as worried about doing that. So, all right. Yep, doesn't have it made, but it does exist here, so it at least knows that it's a thing. All right, so our push button is there. We're going to need a quantity for some of these things. All right, so this part goes here. It'll be J10. And then we'll try and use the stuff from this same series when we're doing other connectors. That way we can kind of only have to buy like one set of crimping tools and things like that. All right, and then so that's the part that's on the board. And then as far as the assembly, we need the button, we need the other connector. Let me check the Molex website to make sure I get the right one. It should tell me the things that connect to it. Maybe not. That's all right though. We'll trust DigiKey this one time. This is something that they're actually kind of known to mess up occasionally, so we will have to double check everything. But it does look right. So this part right here. 3764. Okay. On this page with the 763, they mentioned the 764 several times, so that should be the right connecting part. So let's add that in. 1. Yeah, I feel a lot better about this option. I know it's more parts, more expensive, and a little tougher to fit everything in there, but at the end of the day, like, it makes it so that if something breaks, it's easier to fix. I probably should have done this on the MIDI controller board, because I have to desolder some wires now to put that thing together. All right, and then we need the inserts for it. All right. We go to this product page. Man, their website is just terrible. I'm just trying to verify that everything I'm connecting together is going to work. Man, it is so hard to search anything on their website. All right, one more try. Sometimes if you put the dash in the right spot. Well, I hope everyone's having a good night. Wow. It's the weirdest thing. Every time I search the part number on their website, it keeps popping up no results, and then I just search it in Google, and it takes me to the page on their website. Okay, here it is. So this is the part, and then down here it's saying use with the 503765 terminal, which if we go here, is this one right here. So that works. Okay. So this is the one I can... use this. All right, so that's all the assembly stuff. And then on the bottom here, we have the header, which we now need to go through and actually make. So let me go find this on the Molex website again. Oops. But we have the drawing, so we can go ahead and make it. I just want to be able to download the model, so I can just import that. All right, so we got to make a part. This part specifically. Create new component. Add symbol. Let's just do a new symbol. That's probably too big. Rotate this 90. Nope. Yeah, that'll work. One, turn off the name. Okay. Two, off the name. All right, and then shrink that down a bit. And then as far as the name of this thing, how do I change this? I have to be able to change that. Hold on. I'm looking in their documentation, trying to figure this out. Okay, it's called the designator. Interesting. That can be directly placed by the user. The designator string can be edited graphically, which is in-place editing. The schematic library editor. Okay, so I'm looking for something probably called like default designator or something. No such luck. I know the resistors do this automatically. Hold on. Let's go here. How do you set the default designator of a part? All right, I'm gonna figure this out. Oh well. I'm sure there's a way to do that. All right. New footprint. First, I gotta find it. Oh, here it is. All right. So this right here is what we have to make. A lot of these distances depend on how big of a part we're using. What is this big square? applied to even circuit products. There's a note here saying this, so. Oh, note 4 is what that says, not note 1. Pattern prohibition area. So that must be somewhere where like the plastic is going to set down on the board or something. Or like the connectors are in there, so we just need to keep out of that area. Okay. That's doable. All right. Interesting reference points here. Huh, all right. Well, let's start going through this. Oh, try that again. There it goes. All right, it is a, oh, wait. We definitely want to do this in metric. All right, it is square part. X is 0.55. It's 1 for the height. And then I don't think there's any hole, so how do we turn that off again? Do we just say 0? I think that's what does it. Yep. All right, positioning. I guess it's 0. No. Doesn't have to be 1. Let's try that again. Designator 6, that's fine. Position, here we go. As far as the Y, we want 0. And the X, we know the spacing between them is 1 millimeter. So 0.5 millimeter spacing between. So just gotta do this 5 and then 1, 2. So over 2.5. One, 2, 3, 5. All right. Zero, and we want this one to be 1.5. 0 and 0.5. 0 and negative 0.5. 0 and negative 1.5. And negative 2.5. Okay. And then we need to go through and 1, 2, 3, 4, 5. Okay. And then the other pads. Need to be 1.26 by 1.3. Rectangular. No hole. Designator, I can do grounds, so G0 and G1. All right, then as far as the positioning, it is, oh, this is confusing actually. I'm gonna need a calculator. The other one was done, everything was done from an origin point. These are and center points of everything. This one is not. So from the center, 0.49 plus 1.84 plus half of 1.3, so 0.65, 2.98. So our y is 2.98. And then our x is going to be 2.5 plus, it's going to be a lot. Let's see. 5 divided by 2 plus 2.5 plus 1.47 plus half of 1.26, which would be 0.63. So 4.875. Change this to G1. And, okay, and then what is the 2.98, 4.875? Negative 4.875 and 2.98. All right, there's our connector. And then I'm going to go ahead and download this model. Give me just a sec to extract it. All right, and then we will add a 3D body. I'm just gonna kind of making this up as I go. All right, generic, and let's go get it. All right. And then no idea if it's correct or not, but we'll try. Oh, wow, that was close. Look at that. Also, I just noticed that our pads are multi-layered. All right, so it's from, it looks like it's going from the center point of the part, so we need to go up by half the thickness of the part, so I need to figure out what that is. Where is my drawing? 1.5 millimeters, so I need to go up by 0.75. All right, so if I make this 0, what does that look like? Nice. 0.75. Okay. And then let me fix these pads real quick. They should only be top layers. This is going to be really annoying to go through and fix them all. All right, there we go. Now we need to center this up. So it does need to go up by the 2.54, it looks like. And then it needs to come over some as well. I think. All right, let's see where this is at. We're getting there. Okay. Looks like they, okay, so they did their origin point from pin 1, it looks like. Man, I'm sure they notate that somewhere. I wish they would tell me in these drawings, though, like where the origin point is from. All right, so we need to go over to 2.5 on the X. That should line us up on the X, and then, okay. And then it probably needs to come down some. Let's see, though. You know what? Hold on. Let me change this color to black so we can see this easier. Oh, that didn't work at all, did it? I guess whatever that default was. Oh, override color. Okay, now select black. Okay. There we go. That's kind of better. It's still... All right. Yeah, we definitely need to come down. But how much? Looks like almost the thickness of the pad, or the, which is 1 millimeter, so 0.5. Where's the, oh man, where's the 0 at? Trying to understand where the origin point of this thing is. It's not right in the middle, is it? Maybe it is. What is the thickness of this, or the length of this thing? 6.9. No, that's what thing's plugged in. What is it actually? It's 4.85 total. Doesn't really say. Well, what's half of 4.85? It's 2.425, right? So let's try that. I think that's too much, though. Yeah. Yeah, that's still too much. Because it's still not lined up there. All right, let's try 2.04. Just based off some quick math. Not quite. Try another 0.5 millimeters back. So 1.54. Nope, too far. I don't know. I'm just guessing now. 1.7? That's pretty close. Maybe like 1.75 to even it. Yeah, that looks the best. All right, we'll go with that. Should all be done here. We'll save it to the server. No errors. I think it worked. Ooh, excuse me. All right. This one. All right, we'll place here. I guess just up here somewhere. All right. Is it J9? It might be J10, sorry. Yeah, J10. All right, and then move that up there. And now we got to connect everything. And I guess we can just kind of pick these at random. But I'll have to go to the pin out on the TNC. Let's see. All right. This will actually get a little complicated. So one side of the button needs to go to ground. It's definitely, so that's, we'll put this one here. And then one side we'll call power button. Whoops. And then I'll have to go into the TNC through a jumper probably. Alright, and then we'll need... Alright, I have to look at this part. Let's see. Alright, we can get rid of a lot of this stuff. Power the anode at 3 to 6 volts and light the red green LEDs by pulling designated contacts to ground as you desire. Yep. So I need to use NFETs. Probably. So the anode needs to be positive. Probably at 5 volts would be ideal. That would make it fairly bright. I'm going to put this over here. As well as this. Oops. So we'll do this one. All right. And then add labels. Actually, what's coming out of the power supply? Do we have a 5 volt just line? Yeah. No. USB 5E, and then we just have 5E. Okay. We want to use 5E. And then we need to red out, green out, blue. Those probably, yeah. Let's call them there, one there, one there. Red out, blue out. Or green is the next one, right? RGB, green out. All right. I think all that works. We just need to drive these somehow through a transistor, one that can cycle fairly fast. So back to DigiKey. Arrays, interesting. Wonder if any of these have easy to solder packages. I need at least 3 N channel. guess we do a 4. See what this gives us. Something like this could work out really well, actually. Could actually, like, put that on by hand. Alright. In stock, active. That's too big. I don't need a lot of power, just a little bit, so... V may apply. Just need one. What does this look like? Turns on and off in nanoseconds. That's good. What is a substrate pen used for? Force leakage, nanoamps, that's good. Threshold voltage. Typically is 1.8. It could be as low as 0.1 though. We will have to put pull downs on those lines. Is this for like 1.8 volt applications? I don't think this will work. I don't think it's the gate voltage max is. Yeah, too high. I'll exceed that. Maybe. I would think this would be okay, but maybe not. Oh, 30 volts is the maximum. Okay, that's fine. I don't understand. I'll need to look up what the substrate thing does. I haven't worked with transistors much, so... I wonder if I just find... Let me go back and let me... Rather than doing an array, just look for single ones. Because I think I could actually make that fit a little better. End channel. I don't need anything that powerful. I was hoping to find something. I don't want anything this big. Something like this, honestly. Here. Let's just do the cut tape. And I guess tube. Something like this is what I wanted. What is this package type called? SOT23-3. Yeah, I think that would be perfect. Let's see. So many options. Let's go with this. This might be a supplier specific. Yeah, this is all Diodes Incorporated stuff. That's okay. They usually make pretty good stuff. I really just want something cheap. Yeah, this'll do. Specs wise, it's excessive. It can handle more than anything I'll throw at it. It's 20 volts, continuous drain. What's the threshold? Gate source threshold voltage. Seven volts. Nanosecond turn on and off delay time, that's fine. Rise time 5.3 nanoseconds, that should be good. Gate source threshold is, I think, okay. Yeah, I think this works. Let me double check. Oops, on the off chance that it exists here. Ah, no footprint. Fine, I'll see if I can find another one. Oh, okay. Yeah, all these are the same package. I could probably just order any of them. Alright, maybe we'll go with this part then. Let's review. Two. That's fine. That's perfect actually. I think this works. Alright, we need 3 of these. Alright, how are we going to do this? First I'm going to go through and turn off all of these names because it's ridiculous. And then we will wire these up. And I believe the other side goes right into ground. Feel free to double check that I'm doing this right. I always get them backwards, so, but I think this is correct. All right, then we have our control lines. How should we do that? All right, and then we name these on the bomb. I might have to move them over a bit. Whoa. What is going on here? Okay. I think some things didn't get connected. Okay, and then those need to connect to the teensy, as well as the power button input needs to connect to it as well. So let me go through my list here. So power button in goes to pin, so PWB. Actually, we'll rename this to PWBN, so it matches what's on my spreadsheet here. All right, so on the teensy, pin 2, I believe. Yep. All right, this is gonna be a lot. Or eventually, this whole schematic is gonna be a lot when I have so many connections. All right, and then these in order. Red, green, and then blue. Okay. And that should fix our buttons here so they all look good now. Yeah, I think that does it. All right, cool. This might be a good place to stop for tonight. It at least gets everything in the gets all that stuff connected at least. All right, let's go ahead and validate this. Nothing. All right. Update PCB document. Validate changes. Ugh, there's always something wrong. Sure. All right, and then everything is stacked on top of each other down here. But hey, it all exists. It's all connected. And our teensy up here is starting to get a ton of wires to it, so cool. All right, so next time I'll work on the other buttons, figuring out exactly where they're gonna, or what they'll look like. I think the ones we picked don't have a package already, so we'll have to make our own. But I think that will, yeah, I can't think of anything else that needs to get done. Oh, I need to add these to the bill of materials. Never mind. One more thing that has to happen. Why is this one red? Weird. If I put it over here, what is that? Oh, it was drawing like a red line or something. Huh. Yeah, like right there. Interesting. Okay. So just the, I think just the MOSFETs. So that would be Q2 through 4. I'll use an A. Here, I'll put this right here. And we'll put all this stuff in. Excellent. All right, I think that's done. And that is another item done off this. So we did this power button. That took a lot just to do that because of the connector and everything, and then adding all this other circuitry stuff in. Next time we'll do these 4 buttons. I don't think there's anything special about them, so that should be a little easier. And then we'll skip the speaker and go to the NeoPixels. That'll require its own fun little thing to adjust the, we'll have to do a level shifter, and the accelerometer should be fairly straightforward. But we will definitely have to make something for them. And then that'll leave just the motor and the speaker. Oh, and the LCD screen. Actually, we'll do the LCD screen right after the buttons, and then we'll jump on all this other stuff. And then do the motor and the speaker, because that'll be the last thing, and that'll be the hardest. And then we'll have our initial schematic done. And then we'll have to see how many parts we have and start figuring out what kind of circuit board we can make, how much room we can have. All right, well, thank you all for joining me tonight. And I will see you all Thursday. Later.